Hello everybody, welcome to Mesh Code. What we're going to be looking at today is Faster Whisper. This is not a tutorial, mainly because I have not prepared, and this is not a tutorial for you to learn about Faster Whisper, although it could turn into one, because this is mostly a stream, and in this stream I just have looked into what Faster Whisper is roughly, and I think I have an idea. But the intent of this video is to explore, learn, and make progress as we go. You can imagine like this to be a stream, and we're going to have some fun playing with Faster Whisper. And I hope you don't waste your time thinking this is a tutorial. Okay, with that just being said, like I said, I have not prepared. I have not done a lot of groundwork. I have done very little groundwork. The only groundwork I've done is to take a look at what Faster Whisper is, and that means just basically reading the description. So I have not worked much on the audio world, and so I thought I'll just give it a shot and take our first steps. So what we are trying to do here, possibly by the end of the stream, is learn about Faster Whisper and see what comes out of this, just even possibly running the readme and making sure it actually works as it's been said, and also think about what tools can be hooked into and things of that nature. And I hope the stream does not become too longer. This is going to be just a slow paced learning stream. So let's get started. What is Faster Whisper? It's supposed to be a faster implementation of OpenAI's Whisper using C-Translate 2, which is a fast inference engine for transformer models. Okay, so there's a faster inference engine for transformer models called C-Translate. Okay, I didn't know that. I know TensorRT, TensorRT LLM, right? And then there are other faster inference libraries, but it's nice to see. So what does the C-Translate do? Really quickly, side note, it's supposed to be faster. How? Less resources. They do, of course, a lot of optimizations, layer fusion, padding, removal, batch reordering, in-place operations, caching, etc. And obviously that's a low-hanging fruit, the quantization, right? They do FP16, BF16, int16, int8. They support different architectures: Intel MKN, MKL, 1DNN, OpenBLAS. OpenBLAS is nice. Well, I mean, cuBLAS. There is BLAS. What is OpenBLAS? Optimized BLAS based on GoToBLAS 2. I see. I mean, we can get deep into the rabbit hole. Possibly that's one of the other intents of this video, is to just at least know that these things exist. We don't have to really learn and deep dive into stuff, but at least know that these things exist. So BLAS, as you know, is basic linear algebra subroutines. It's a way to optimize, common mathematical operations like GEMM, general matrix multiplication, or GEMV, general matrix vector multiplication. So CUDA has their own version called cuBLAS, right? You have AMD having ROCm BLAS. You have other BLAS implementations, and OpenBLAS is supposed to be an optimized version of BLAS. Okay, fine. Alright, so BLAS is used by this, OpenBLAS is used by this tool, the C-Translate. Okay. Parallel and asynchronous execution. Batches can be processed in parallel and asynchronously using multiple GPUs or CPU cores. Dynamic memory usage. The memory usage changes dynamically depending on the request size while still meeting performance requirements thanks to caching allocators on both CPU and GPU. What is caching allocator? Well, I mean, I know caching allocator. Let's just quickly take a look at caching allocator. The goal of CUDA caching allocator is to reach a steady state where the program runs without needing to request new memory from CUDA, malloc or CUDA free. PyTorch relies, I mean, you know, if you know a little bit about CUDA, maybe we can do a video about CUDA as well, fundamentals. And it's a very interesting, performance improvement topic. And if you're interested, maybe we can take a look at it. So there is CUDA malloc and CUDA free that pretty much does CUDA memory allocation on the GPU and frees the same allocated memory. So PyTorch relies on the CPU execution running ahead of GPU to hide the latency of Python interpreter behind the time-consuming CUDA ops. But these memory APIs, especially CUDA free, introduce synchronization which interfere with this process. To accomplish this goal, the caching allocator requests blocks of memory from CUDA and figures out ways to split it up and reuse these blocks without returning them to CUDA. So why not just request all GPU and manage it inside PyTorch? Yeah, PyTorch is not the only library to use CUDA APIs. Many programs will use cuBLAS, cuDNN, Nickel. cuBLAS, like I said, it's CUDA BLAS implementation. cuDNN is CUDA's deep neural network implementation. Nickel is NVIDIA Collective Communications Library. This is what is used to do multi-GPU training, all of which do some allocations on their own, and users might mix PyTorch with other CUDA accelerated libraries we do not know about. Instead, if PyTorch ever uses n bytes of memory at one point, we will continue to keep that n bytes cached until specifically frees via CUDA memory empty cache. So this is trying to mitigate the overlapping introduced by the CPUs, if I'm understanding correctly. The caching allocator requests blocks to PyTorch relies on CPU execution, yes, but these memory APIs, especially CUDA free, introduce synchronization which interfere with this process. Well, that makes sense. So we are basically allocating a block of memory, and we will continue to keep that n bytes until a user specifically frees. Under normal circumstances, the allocator achieves these goals and mostly lives in the background, but sometimes a particular set of adversarial allocations might prevent it from reaching a steady state. Or maybe a program runs out of memory for good reasons, but it is hard to read the statistics. In these cases, it's helpful to understand more about what the allocator is doing to debug the issue. Overall approach for allocating is simple. We maintain a cache of allocations that we have previously gotten from CUDA and will attempt to reuse. So it's pretty much like you're minimizing the freeze, CUDA freeze, so that way it doesn't interfere with CPU, I guess. So you have a block, pool, small pool, large pool. For less than 1 MB small tensors, we use a separate pool to avoid fragmenting. Yeah, because if you keep using memory allocations, you can have internal fragmentation. At a high level, we tried to find a free block from this pool, but CUDA asks for memory otherwise. The allocation starts with some cleanup, that's using streams, and allocation rounding. If the size to be allocated, then it uses a best fit strategy, finding the smallest block that fits the allocation. If none is already in the cache, then we are not yet in a good steady state to ask CUDA for more memory. Blocks are rounded as per CUDA stream. Each CUDA stream will have its own cache of allocations, with rebalancing done only by emptying the caches in low memory conditions. Okay, so I love the flame graphs. It's a way to identify hotspots, right, by CPU. But quickly to summarize what I understood from this is it's a way to mitigate the overhead caused by the allocations or deallocations, and it keeps that memory in hand until it's needed, even if it's coming at the expense of some extra memory used when it's not really needed. Well, that's the impression I get. But let's keep moving forward. At least we know there's a thing called caching allocators on both CPU and GPU. That's why the name caching allocators. Where you just allocate and hold it. It's almost like caching the memory. Sweet. Okay, we can learn more about caching allocators. Yeah, we can learn more about caching allocators later. Let's just quickly take a look at CPU. Okay, there you have PyTorch's source code. Maybe I should zoom in a bit. Can a custom allocator improve cache locality for lists? Cache locality is when, if you're able to access one element, you should be able to access the next immediate element, so that way your cache hit rate goes up. Yes and no, but leaning mostly towards no, at least if you use the list in a way that lets you get anything out of it. Okay, so if you do insertions and deletions at arbitrary positions in the list, even though you originally allocated nodes in linear order, you end up in the order list no longer matching the allocation. In this case, a custom allocator might still do good. At least the nodes in your list won't be mixed up with other data. So you might improve locality of reference at least. Yeah, alright, so let's keep going forward. There's a thing called caching allocator that helps to mitigate latency. So dynamic memory usage is enabled by these caching allocators. Lightweight on disk. Quantization can make the models 4 times smaller. As you know, that's normal, right? Because if you are reducing the number of bits, that means you are effectively, your memory capacity usage also goes down, because now you're storing less. And also what it also implies is you don't have to do a lot of more computations, so it reduces the compute intensity as well. So that's where you get the 4 times smaller on disk with minimal accuracy loss. Well, I mean, this is what does minimal accuracy loss even actually mean? So we should look at the numbers quantitatively. And then there's a thing called simple integration, has few dependencies, expose multiple APIs in Python and C++ to cover most integration needs. Configurable and interactive decoding. Advanced decoding features allow auto-completing a partial sequence and returning alternatives at specific location in the sequence. Support tensor parallelism for distributed inference. The model can be split. That's tensor parallelism, right? You can put the model's tensors in different GPUs, so that way you're able to fit the model. But also that means increasing tensor parallelism also means increasing communication, which adds more latency, but at least you're able to get it to run, so that's a win in that sense. Okay, so now we know ctranslate2 is a optimized inference library for transformer models, and it uses these techniques to improve the performance, right? And of course we didn't go in depth, but it's a good understanding. It's just decent enough to have and see where we go with this. Okay, wait, this is OpenNMT. This is probably from Facebook, correct? Let me check. Who maybe not. Who is OpenNMT? OpenNMT. Who started this? Systran and Ubiquitous. Okay, this is by Harvard NLP. And Systran. Well, I mean, Systran is the author of Faster Whisper, correct? Okay, so nice. What do they have? Servers? Model training, cloud. Well, I mean, cool. They have an open source library and they have a way to monetize it as well. So let's say your enterprise. Okay, we have to contact them. If you are a professional, okay, they give you translation, text translation, PowerPoints, pages, languages. Yeah, I mean, this is a nice business model. I mean, straightforward, right? I mean, that's one other approach to think about it. If you do annually, it's 34. If you do monthly, it's 44. Okay, cool. Let's go back. And if you don't know flame graphs, it's pretty similar. This is what is a flame graph. It's kind of like you can think of it like a profiling timeline. And you can see at the bottom what you're seeing is what started this process, and then at the top really you'll find out who is the culprit, actually adding a lot of slowness to your workload. So here in this case, maybe this guy is a culprit and it's doing something, right? So you see all these. Sometimes it could be this guy who is responsible for adding more heat. It's kind of indicating which process in the launch, right? You do a join and then create a sort index, file sort, find all keys. You keep going down all the way, and then you find out who is responsible for an extended version of your application to be slow. It's a latency marking tool. It's a pretty cool tool, and developed by Brendan Gregg, and I actually like Brendan Gregg. He's a nice. He's got a lot of nice talks. So let's come back to Faster Whisper. We know it's using C Translate 2, and it's supposed to be 4 times faster than OpenAI Whisper for the same accuracy while using less memory. The efficiency can be further improved with 8-bit quantization on both CPU and GPU. So you have Whisper, right? They compare the numbers, and these are of course provided by the authors, so we should obviously treat it with whatever respect it deserves, also whatever slight criticism it deserves. But let's not always be critical. Let's take a look. So they claim that OpenAI's default Whisper version runs in 5 minutes, and Faster Whisper runs in 60 seconds. I mean, yeah, it's about what, 5 times? I mean, they said 4 times there, but yeah, sure. It's 5 minutes and 1 minute, so that's 5 times faster, which is pretty cool, right? So if we can get it to go 5 times, or approximately 4 times faster, approximately 5 times or 4 times faster, it's nice, and it only requires about 5 gigs of memory. The good news is I have a GPU today, and the GPU is not too fancy, but it gets the job done. It's a 1070, and I actually took some time to install the drivers and the latest CUDA version at the moment. As at this point in the recording, I'm actually on a Saturday, June 22nd, 2024. So let's find out what is going to happen, and if we can actually get something going. I just pretty much all I did now was install a fresh copy of the Ubuntu operating system, and inside I actually like to work with the default terminal from Ubuntu. However, I thought, you know what, let me just give it a shot. These fancy terminals, I thought I'll just give it a shot with Kitty. And this Kitty is supposed to be faster and more efficient in terms of display, and also you could see that Kitty is also using a little bit of GPU, so it uses GPU to render itself, and it's not too bad. So I'm okay with this, and if it's a bottleneck, we'll switch to Ubuntu's terminal. I also installed ZSH with Powerline, so that's your basic display. I mean the terminal. Bash equivalent. It's ZSH is your shell. So let me see. Yeah, so what we can do now is sort of get started. Yeah, so let's see. So we can get started with the installation and see how this goes. If it works, that'd be awesome. So we're going to test it out and see how this works. So if you want to run it on a GPU, the GPU execution requires NVIDIA to be installed. We need cuDNN and cuBLAS. Well, I think the CUDA toolkit comes with it. So if I'm not wrong, I mean it should, right? That's how we are able to get the works going. So all I have is like a simple let me show you my system config, so that way you know what's going on here. I have what, Intel i7-67. This is a gaming laptop, and all I have is like an old CPU. I have what do I have? I have old GPU. Really, at this point I should be running on a 4090, but you know what, not everybody's got 4090, so let's see if this even actually works, and that's the interesting part. So I have what, a 1070, and if it works, it should easily be workable on a 4090 as well. And let me show you my memory. So I got like what, total free memory is about 16 gigs of memory, so it's not great. And we saw the CPU memory. Yeah, the storage is what, the storage is not great either, so I'm running it on a supposed to be a 512 gig SSD, so it's still, I only got 468 gigs, right? I mean, that's normal. I showed you my memory capacity, I showed you my CPU, my GPU, my storage. What else do I need for you to see before you can replicate this? I think that should be all. Alright, so if I remember, I'll come back to this. And you can also comment in the video, and then I'll be able to respond to your comments as well. So let's get started with the installation process. Do they have a Docker file? They should have a Docker file. Well, I mean, that's the easier way to do it, right? You go from CUDA, you install Python, you copy this Py, you install Faster Whisper, and then there you go. Alright, so maybe a good idea for us to get started on is like to either do the Docker pull, or we could really get started with just doing a conda install. It doesn't matter to me, but I say maybe it's not a bad idea to do conda install. Conda install. Now conda installation is going to take a couple minutes. So would a Docker file build. So I'd rather do conda installation. So let's quickly install conda. I am going to do mini conda because, of course, for the obvious reasons, we really don't need full conda, right? So anaconda is not needed. So installing mini conda. So over here, I'm going to go to my Linux installer, download the pkg sh, and that's it. So what was that? Download the copy link, right? And I just do, I go to my download. I don't need to go downloads, I can just try it later. So I can just do, why is it pointing me to Miniconda? Supposed to go to a package installer, right? Yeah, let's go here. Okay, let's go to Linux. Yep, let's copy this and let's paste. Alright, so this is downloading. I should hardwire my laptop, but it's not horrible. So while that's happening, we can see the other steps that are needed. You just pip install, that's it. Well, I mean, it says that you need cuDNN and cuBLAS. Let me just make sure if I have cuDNN and cuBLAS. Can I download the cuDNN? Yeah, it should be. And I think I exported to path. That's supposed to be it. Right? Did it download? What happened? There we go. Linux, x86, Ubuntu 2204 network. Do I not have cuDNN? Let's actually open a tmux session. Okay, tmux ls, tmux. What happened? Tmux install? Why is it exiting? That's weird. I just told it to create a new session. I don't know. Why is it exiting? It shouldn't be exiting like this. Tmux new session -t. I don't know what happened. Okay, so I just put alias and it's not happy with the alias, looks like. Okay, so over here, if I have cuDNN, there we go. I have cuDNN installed then. Oops, not cuDNN, it's cuDNN. Do we have cuDNN? I'll take it as it's installed. And it also said it needs cuBLAS. Let's see if cuBLAS is also... Okay, cuBLAS is a part of NVIDIA HPC SDK, which makes sense, right? HPC is high performance computing and kind of what the modern deep learning training stack is. It's like you have an infrastructure set up to run really large training or really large simulations. HPC is how can you bring a lot of compute, a lot of storage, and very good networking, and make the computers run as fast as possible and extract the highest performance possible. So that's what is HPC. So of course NVIDIA has been a big player in HPC, and you know, you probably won't find another player. Well, I mean, we have AMD and others, but NVIDIA has been a very good cornerstone. It's like the poster child for large-scale HPC training or other, I mean, large-scale HPC workloads. So let's see, bundle with the newest plus 2 CUDA versions. Let's see. I don't want to really install the HPC SDK. If I can, I'd rather avoid installing. We'll find out. I think if I have a CUDA toolkit installed, it should come with cuDNN. If not, we'll find out. and we downloaded that, so we just have to chamad my Miniconda. Why is this not working? Chamad plus X. There we go. And we say Miniconda install the sh, enter. Okay, I agree. I mean, this is where you would probably use Docker. It's much faster, but I want to be able to, get to a point where I get to run this for other workloads as well. So I will continue installing Miniconda. You can do auto active base false. I mean, do we really want it to be active? I mean, we can always revert it back. Sure. I mean, we can say yes. Alright, let's just be default. It's okay. Yes, so I have to restart my terminal, correct? If I recall correctly. Okay, so Conda, no? I thought we had it installed. Oh, maybe it installed for my, I see, for my actual terminal, not for Kitty. Control RT. Let's see. Conda, no? I think, oh yeah, I think I should do Conda. Well, I mean, Conda init will not work if there's no Conda, which sucks. I should have noted what it said. Let's see what it says. Okay, let's see what is in here. I may have to just ask it to do cd bin, no bin, maybe conda bin. Oh yeah, so I have to get into /home /mesh code Miniconda, and I'm gonna go conda bin or bin. There we go. No conda here. Where is Conda then? Where are you, Conda? Where are you? Where is Conda? Let's go back to installation. If you're unsure of the prompts, accept the defaults. You can change them later. To make changes to take effect, close and reopen your terminal window. Did I not do that? I thought I did. Okay, so let me open this. It's not here, which is sad. If it's not here, where is it? And it's supposed to be a Miniconda 3 bin. Okay, there we go, Conda. What? There is Conda right here. What are you talking about? There's no Conda. There you are. Sweet. I have to add this to my path. I mean, like, that is crazy. If I can't find my Conda. So let's just export this to my path. So what, obviously this is not tutorial, like I said, this is just fun exploration. But if you don't know what I'm doing here, I'm just adding to the path, so that way the Conda gets recognized. And in fact, I should really echo this to my, I have a source me file that I use. So that every time it is added, that thing is loaded. Sweet, it's added. Yeah, okay, well, not too bad. I would have thought it would add it with the variable, but it resolved the variable. It's okay, I don't have to worry too much. So now we have this, right? Conda env list should, yeah, of course I have to source my ZSHRC, and now we have this trouble. This is, you know, after installing the power line, that I get this stupid looking thing. It's okay, I'm gonna have to, every time I see that happening, it's my sign to restart it. Conda, I have to go fix it. Okay, so I don't know why it's not sourcing my source me, at least. What is going on? Did it not add? Oh gosh, it took out my other contents. I thought yeah, it's too bad. It took out my other content. I had a little bit of more stuff in my source me, and it's gone. Horrible. I should have thought about it. Yep. Here we go. Okay, but at least if I can source my conda. Why can't it source? Let me actually check what is the comment. What is the source me command I put? Oh, too bad. And I really don't like that sound. I really have to do something about that sound. First, let me add a few aliases. And that would work. And yeah. And actually, how do I make that sound go away? Ubuntu remove terminal sound. Terminal sound is there was a command yep, this is it. That's the command. Okay, and there was a sound to command to remove kitty as well. Remove I don't know why they even added. Yup. It's like, I don't think people like this stuff. And still they like to add it. Like weird. Bind command not found? Well, at least well, let me not worry about the terminal. I'll worry about it later. I got my kitty to work, so that's all I need. Okay, cool. So we have conda. Yep. Okay, so now I'm going to install I would say, do I need PyTorch for this? I suppose so. Let's go install. Do I need PyTorch? Let's take a look at the requirements. Hugging Face Hub, tokenizers, Onyx runtime. Why do I need Hugging Face Hub? To download the model? Do I have to put my token somewhere? Okay. Well, if it's asking me to do stuff like that, I am not prepared. If it's just a straight easy download, I'll do that. Because I only have one monitor and I'm sharing that, so... Well, I have other choices. Maybe I could use the token and disable that token when I upload the video. That's another thing I could do. Yeah, so I'll go to conda install and I'll create a fast whisper. And oops, I think the install is not the command. It's supposed to be conda create dash a new environment called fast whisper. And what is the Python version? Do they mention the Python version? I'll take it, of course, Python, whatever, Python 3.1, 3.0, I don't, doesn't matter. Nope, fast whisper, and Python should go after fast whisper. Okay, that's okay. Python equals 3.0. Maybe that's how I do it. If it doesn't work, it shouldn't be a problem. Yeah, cool. This worked. And while that's happening, let's go ahead and activate the environment. Conda activate fast whisper. Run conda init before conda activate. Sure, why not? What's going on? Oh, okay. I have to close and reopen that thing. Sure. Let's open that. I thought we closed it, didn't we? Oh, that's a different terminal. Okay. A different kitty shell, kitty terminal, whatever. Okay, so can we just like get a fresh... What's going on? Why won't you close? This is ridiculous. I'm actually opening it with the shortcut, but looks like the shortcut tries to bring up what was already there. I don't understand. I am typing exit. That means it should go. I don't understand. Oh man, I have no clue what's going on. But let me close this. And let me actually open... Let's do this. And let's actually kill that kitty. What's the command for kitty? Can you find it? Can I find it here? I have to search for it. I think there's a way to... I forgot the way to search. Command is kitty. Okay, yeah, so I mean I could do a ps-aux and ps-a and grep it with this. There was a way to find from, maybe it's O? I think it's called O. Yeah, that's it. That's the command. What? So it's not there? It's not there. Okay, where's that? There's got to be a thing for kitty. Maybe it's not called kitty. I think it's something else. What the heck is the name of the process? Or maybe I should filter by user. I think the command for that is U. Yes, U. Let's go find out who that guy is. Firefox, Pulse Audio, that's the recording. Where on earth is my kitty? It's a funny name, kitty, really. So, I wish they kept a different name, but I can't find that now. I can't find my kitty. So, where is kitty? What is the name of that process? I could like blanket delete all the stuff that I'm running, but I don't want to do that. Okay. Alright, so I'll just give up on that and try to resolve it through here. Wait a second. I think that this is a new instance, and every time I open an instance, this is what's going to happen. Oh my god, why didn't I realize that? I thought it's not closing, but it's actually closing, and every time I open this is what is going to be produced, which is kind of weird. I have to look at how to mitigate that problem. I'm not going to do that today. Yeah. Let's make sure that is what is the command. Is that the command? Okay, that's quickly glancing at it's not the answer. Okay, so I'm gonna have to use this, right? This is what I have. Oh, it should be in my kitty config, not here. Alright, yep, that is fair by me. That is fair to me. So I go to my config. Man, it's annoying. Kitty config. Yeah, okay, so let's see. Enable audio bell, right? Okay, is it gone? It is gone, right? I suppose so. And let's take a look at my source me. It's not gone. Why is it gone? Let's exit this and see if that helps. If it's not gone, I will work on that later. I'd rather start working on the actual meat you all are waiting for. It's stupid I have to work on all this getting started stuff, but hopefully this may be useful for somebody who is getting started just like me. Okay, so what I have is everything is okay. Let's see. It's not making any sound, which is fine. Okay, so I go conda env list. Cool. Conda activate fast whisper. What the heck? Conda init. I did run init, right? What is the actual problem here? No action taken. What the heck is it saying? Why do I have to keep running conda init? Yeah, what's going on? Okay, that's the key. Ah, Conda init ZSH. That's right, I'm using ZSH. See, that's what happens when you use these fancy things. You have to make sure you're running for it. And let's see, we go open, and then we open this. Kinda look, I have not used a lot of ZSH, so apologize for me being a total amateur. But here we go. Sweet, we activated Conda Whisper. Terminal's database is inaccessible. What? What is now this problem? Terminal's database is inaccessible? What the heck is that? What? Oh, removing Anaconda path from this solved the issue? Really? How does that interfere? Conda install. What is the fix? Oh, sweet, sweet. Okay, wonderful. Okay, I love it. I love it. Basically, there was a conflict, and that's what they mean by interfering. Excellent, excellent. You know what? This is the kind of problems I love to debug. Okay, now that this is working, so let me just do conda list, and it should basically have these fundamental Python libraries. Okay, so now let's actually do, where was I? Close. What? Actually, there was another one that the, let me see. This is Whisper. I was looking for, not this. Yeah, where is that? Okay, maybe that I closed it. Yeah, I closed. I was looking for, there was a tab that I probably closed. I was looking for the, the developer. The developer of Kitty had actually made a comment. Maybe this is it. Yep. So in the bottom, I thought I saw the developer. Okay, I can silence that way as well, but I'm okay for now. But he is supposed to be the developer of Kitty, and he had made a comment. So I was looking for that particular comment where he said you have to disable that sound by running a certain command, and I thought my command I had run was not actually what he had mentioned, but it was a similar flavor. Okay, so let's get started with the installation. So I go up here, and I'm actually a bit hesitant to install Whisper just like this, because from what I recall on the README, it's AV, C translate, Hugging Face Hub, tokenizers, Onyx runtime, and that's it. Is that what it is? So let's take a look at benchmark, memory benchmark, requirements benchmark. What is a requirements benchmark? Yeah, transformers, memory profiler, evaluate data sets. Sure. Maybe speed benchmark. We can run the speed benchmark today and see how that behaves. According to their README, to get started, I have to do faster whisper, import whisper model. And faster whisper is over here. Okay. Everything's importing from this. Alright, I guess I'll just run pip install and find out what happens. I was just a bit reluctant to do that because maybe I have to install PyTorch or PyTorch with the cuDNN and something like that, because PyTorch installs with cuDNN when you do a conda install. But we'll see. If it doesn't work, we at least can come back and take the other route. So I go pip install on this, and what was that? I go here. What? So this clipboard is not working as I expect it to be, and that's a little bit of a pain. So I have to right click, copy and paste, which is, again, I'm not even able to right click, which is so sad. I can't even right click. It will not show me paste, neither will it show me. There you go. I had to like click on my mouse wheel, and that's a little sad affair. I need to still fix that problem. The problem of, is this going to install the GPU version? Everything seems to be CPU. So if it doesn't install the GPU version, I have to think about, I mean, I can go and do the GPU rounds as expected, but you know, that should be okay. I'll just give it a moment. Okay, did we install GPU? Well, that's happening. Let me do something else here. Okay, so there you go. C transformers with CUDA. That should be it, I think. I don't want it to run on just the CPU, right? Because it's obviously going to be slower. I want it to run on the GPU. I think this is not what we're looking for. Faster whisper. Let's go to our, maybe they have a CUDA installation. C translate to, oh, it's not C transformer, it's C translate to. Okay, so should be having CUDA support, right? C++, where is CUDA? No CUDA here? Well, it claims to be working on GPU, so let's take a look at their requirements quickly. And no? Okay. PyBind, setup tools, Python, C translate, which is okay, but I'm looking for the GPU version. Why can't I find a GPU version? Maybe I should do it differently. Alright, so let's see if this is okay and it works. If it works on CPU, we can worry about making it work on GPU later, I guess. So now I do pip list, right? Okay, C translate 2 is here. How to get C translate 2 working on the GPU? Let's not. I mean, this is my easy route. I can just do a Docker pull, and that's the reason why I installed Linux. It's much convenient to deal with these type of problems on Ubuntu as opposed to Windows Docker. It's pain. Compile the Python wrapper, compile the C++ library. Okay, I suppose maybe it works out of the box. Can I just do GPU device? How do I do GPU device? Device is GPU. Let's check. Okay, it's CUDA. There's a CUDA device. Alright, CUDA. If I just give CUDA, that should be okay. Let's just run this. I mean, what's wrong? Right, C translator on CUDA. Yay, let's do a simple C translate to run. Super simple, and we just put it on CUDA and find out what the heck is going to happen now. Okay, so yay, unable to open file model.bin and model C translate. But it didn't have trouble saying. Actually, it did have trouble. Can I not find an easier way to debug this? I don't want to be debugging the model issue now, because we need to go back to our original problem. Okay, there is the model. Okay, that's easy, I suppose. If it's not too expensive to download and try it. Yeah, let's do this. I guess this is easy, right? This is easy as a quick start. How big is the model, I wonder? Oh my gosh. My poor 512 gig system will not make it, I guess. After it's done, it's just 346 MB. That's not too bad at all. After it's done, I'm gonna have to clean up a lot of stuff. That's the downside of having a system like this. Yeah, let's wait for this, and if the GPU thing works, I'm happy. I'll be very happy, so I don't have to worry about anything else. And then we can run the base faster whisper here. I mean, we could do faster whisper straight up right now. Yeah, I mean, we could do that. Let's actually open another. Alright, let me do this on a TMUX session, so that way we are ready. I think it's called install, of course, because the alias is gone. Let's quickly add that. TMUX A is this. Okay, so TMUX A install. Okay, that's right. That's right. Okay, now what? attach session. Did I mistype it? What am I missing here? Ah, okay. Yeah, of course. That's right. There's no install. Let's do this quickly. Then let's do this. So I'm gonna do tmux a install. Boom. There we go. We have this boring 9 session from CUDA that was okay. Tmux a install. Actually, I really want to now rename it to run, right? Run C translate or run whisper, run F whisper. Cool. So now I just need to get into faster whisper directory. Never mind. So it's where is that folder? I thought it's inside faster whisper, right? Yeah, why can't it get into faster whisper? Am I missing something? Is something wrong with me today? Let's check. F. Okay, so F whisper or something? What is going on? No such file or directory fast whisper. Then where is that thing coming from, really? Okay. Oh, I should be already in the fast whisper directory. Man, what are you doing, man? Mesh code, you need to learn, buddy. Okay, so tmux attached to this. That's right, we added that. What? Let's take a look at what am I. Tmux A is there, right? Oh, tmux N is not there. Good, good, good. Tmux N is new session, and that should be. I think that should be it. Let's find out. Okay, cool. So now let's go into faster whisper. What is going on? Where is my fast whisper code? I thought we had it, didn't we? What is this actually? What is this really? I thought it was a folder, wasn't it? Oh, it's Conda environment. Yeah, that makes sense. That makes sense. Okay, so I'm gonna have to clone this or create a new directory inside so I don't mess around here. Okay, so I'm gonna move this C translate test to faster whisper, and now we should be ready to go. Cool. Great. Now it makes sense. And now I'm inside the base, so I'll actually Conda activate. Now we are talking. Alright, so now we are inside the fast whisper Conda environment, and then we are inside the faster whisper folder. Let's give it a shot and see if we now are able to actually get that C translate 2 to run on a GPU. and we probably have completed the download. Let's move this transformer to Faster Whisperer folder, and let's get into Faster Whisperer. Okay, so I'm in here, and inside the Fast Whisperer we have this Fast Whisper sample from C-Translate. Where is that C-Translate documentation? I thought I saw C-Translate documentation. Wasn't I seeing that? Okay, maybe not. Wait a second, where did that go? Okay, there you are. Quick start on the C-Translate too. Perfect. So now actually let's also install this other necessary package just to make sure we have what is needed. Sentence piece is already there. Open an empty. Let's see. Okay, so while that's happening, let's create a so let's do C-Translate to test. I'm gonna delete everything and get the basic running. I just need to make sure it runs on the GPU now. So I'm gonna insert, there we go. And let's put it to GPU, HPU, Habana Processing Unit. We'll get there. Maybe one day Intel's Habana gets, maybe it's, can you access Intel's Habana on a cloud? Let's check. Habana Cloud. There should be a way. There you go. Habana Labs. Okay, high performance, high efficiency. Can we access it? Is it available in a cloud or rent it? Okay, sweet. Habana Gaudi Accelerator, Habana Labs. It's available, huh? I love it. Nice. Okay. It's at least available, which is good. So one day maybe we type HPU as opposed to GPU. But now I'm gonna have to type CUDA because that was what was expected. Okay, so now here I'm gonna have to extract this. Okay, let's see. Okay. Alright, so after the extraction, let's take a look at the code. Okay, so we have that sentence piece, processor, hello world, and it's supposed to encode and translate the input tokens. And output is the results, and decode and output that. Okay, let's see what happened here. Still installing. I knew it. It's supposed to need to install Torch, and it's installing the CPU version, which is okay. We'll see what happens. Okay, so we're still doing CUDA Kublas. Alright, let's give it a moment, I guess. While that's happening, let's see what else is needed for this to actually work as expected. ENDEC translate. What is ENDEC translate actually going to do? I like the C API. Nice. Hello. What is this language? Is it French or it's DE should be what? DE is German. Deutsche. Deutschland. So okay, there we go. That's the next step. We need to do conversion of the CT2 OpenNMT converter to from the PyTorch's 10 epoch to ENDEC translate, and that is OpenNMT conversion that goes on. Convert the model to C translate to format from PyTorch. Sure. And while that is going on, I have to first clone the repo. Isn't that something? I have to clone the repo. If not cloning the repo, how is that I'm supposed to get it to work? Okay. Let's CT to OpenNMT. I suppose Llama 1 maybe? Okay, sweet. Okay, and I'm gonna have to download the repo here. OpenNMT. This is it. Wait. Not OpenNMT. I think it's supposed to be C translate, right? C translate to. Yeah, good. And I need to find the conversion script. It's C translate to converters. What is it called? It's called ct2 OpenNMT.py. Wait a second. Converter. Is it supposed to be installed after is it supposed to be available, that command, after this thing is installed? Let's check it out. Yeah, it's supposed to be available, huh? Okay, cool. As a command, it should be available. And it will not be available if I don't switch. Conda activate fast whisper. Cool. Now let's see if that works. There we go. Okay. So it's available. Why don't I get started on the conversion? Model path is my average 10 epoch, and the output directory is a directory that I am yet to create. so that this thing actually recognizes that this exists. Cool. Let's go back here. Whoa. Oh, okay, that's fine. Let's make sure there's nothing here. Yeah. It's going to create a directory for us, so why bother creating one? Okay. Ah, come on, stop the command. Ooh, pipe torch not found. Why is torch not found? This copy clipboard is slightly annoying. I have to work on that. Okay, so I have this, right? It's compiled and my file converter needs torch, and allegedly torch is not found. Okay, so I'm gonna have to go Python 3 import torch. Yeah, alright. Maybe give it a moment. I thought I saw it was installing torch. Maybe when it recognized it needs GPU, it probably uninstalled it. Okay, so while that's happening, let's take a look at, once that is done, the end output is this. Okay, so you have a translated version output. It should say hello world. Hello world. Okay, that's German. Yeah, hello world German. Yeah, oops, this is still running. Well, I mean, the text was right there. I don't know what I was thinking. But I wanted to verify, I guess. So, okay, so I mean, if it's running, I really don't know why I'm trying to do the, well, I do know, but maybe that step was, possibly you could avoid that step and directly go to this step with the fast whisper model. So we do fast whisper, and once the fast whisper is installed, you can just launch a transcription from a whisper model. And a whisper, as you know, is speech to text transcription model, and that will basically give you the output. I could have done it right here with CUDA, right? I don't know why I did that, which is stupid. Probably because now, because I need this, it probably is going to install a bunch of other libraries. Alright, let's see. At least you got the CUDA versions, so I'm pretty excited about that. And did we install Torch or no? Ooh, we're slowly uninstalling stuff too. No, we didn't install Torch. I'm actually excited for the NVIDIA versions over here. So let's give it a moment. Where is Torch? Do you see Torch? I don't see Torch. Triton, CYMM, Wasabi, Waitress, Triton, Tabulate, Spacey Lager, Spacey Legacy, 6, Shellingham, Regex, Rapid Fuzz. Whoa, are we done? No Torch? Okay, sweet. Cool. I mean, it's there with CUDA, which is nice. Okay, well, I'm happy that CUDA is here on this and Torch is here, so why don't we just play with this now. And GPU is actually working, so lovely. Cool, I'm happy about that. So I'm gonna have to do C translate test.py, but before that I have to convert the model like we saw. Of course, no module named ONMT inputters.text dataset. You know, I could go debugging this, or I could go and get the faster Whisper running. That was our actual goal. So I'd rather focus on that as opposed to OpenNMT to work. I'll just drop that at the moment and then we'll come back if needed. So I'll just see if I have to install anything for the faster Whisper to run. I thought I had cloned it, haven't I? But if it's not there, that's okay. Let's come back here. Copy and paste. No, it's pasting the wrong thing. You're pasting the wrong one, buddy. Okay, git clone. Let's try to clone this. Alright, everything's here, so faster Whisper should work. So that means I cloned it earlier, didn't I? No, I didn't clone it? How is everything there then? Oh, I did a different way to install it. Alright, that's cool. Let's go here and run a sample on the faster Whisper. And to do that, this is the fast version. Okay, so I could do I want to run the larger or medium one? What the heck is gigaspeech? I know WER is word error rate. What is gigaspeech word error rate? I'll take a look at that. I say we'll just run the simpler FP16 with 5 gigs of memory. That is the large V2 model. Cool. How do I find large V2? Do I need distal large V2 or do I need... doesn't matter. I think we'll keep the distal large V2. There's a large V2 as V3 as well. But I don't want V3. I'll do the V2 because of my GPU constraints. Right, I will do large V2. I don't mind distal V2. Shouldn't be a problem. I need an audio.mp3 file. Where do I find my audio.mp3? They probably have a a 13-minute video of
drinking warm water before bed balances blood sugar levels and reverses type 2. Thousands
of this video. What appears to be French, right? What appears to be French. Ted Orleans.
Bonsoir. L'étendue d'eau qui ne sert à rien, en fait.
Of course it is French.
L'oxygène qu'on respire. Donc en fait, on a perdu 40% de la population du phytoplancton sur les 50 dernières années. En grande partie parce qu'on a exterminé les baleines au XXe siècle.
Cool. So there is the equivalent of the
version.
So why don't we download the MP3 for
L'homme,
this?
Lui, va en mettre.
How do I download MP3? Is there a script that they provided? I can download it on the internet, but I rather not click on some stupid website with a lot of garbage ads. Did they give us an audio.mp3 by any chance? Never mind. Okay, so let's try and download the data set, or I mean the inference. Download mp3 from YouTube. Okay, let's give it a moment, and I'll give you my audio.mp3 file, the exact same file. Download. Of course, I'm given a bunch of ads that are okay. So I downloaded this and I have it here, and I have to. Okay, so I'm gonna have to rename this to audio.mp3. I'm just gonna leave it there and get the basic thing to run. Yep, audio whisper large v2 or distill version as well if I run out of memory. Now, do I have to download anything from Hugging Face? Maybe not. We'll find out. I mean, it should, because you need the model. And by that I mean, do I need to add the token? Maybe I should clarify. So actually there's a benchmarking folder too, and they have everything. So why don't I try to look at the speed benchmark? Measure speed, time it, and what are they benchmarking really? Time it, repeat. The function being inference, correct? Passing inference. What is inference? From utils import inference. Okay, so what is utils inference? Benchmark this M48 file from French and output large v3. Do we need large v3? I don't. Let's see if I run out of memory. Sure. So let's do the speed benchmarking, and okay, cool. I don't have to worry about downloading anything. Okay, sweet. Is it doing anything on the GPU? It doesn't seem like it. Maybe it's downloading the file. Yeah, it's being downloaded. That's right. So let's actually delete the file that we don't want anymore. Faster Whisper. You know, there was a full model that I downloaded that is unnecessary. So we can delete the averaged 10 epochs and transformer. Yeah, and even the sentence piece model is not necessary. Cool. because I'll run out of space in no time. This is just 512 gigs. Not even 512, it's like 450-ish something. So, okay, so while that's happening, why don't I go back to this and take a look at what these benchmark scripts are actually. We did see that it's actually inferencing, it's benchmarking the M4A file, which is nice. I'm glad they provided that file. The memory benchmark, normalizer, requirement, speed benchmark, and utils. They're benchmarking the utils. Function, run, get result, right, parameters, and it's probably, if you choose the my thread, who's using my thread? It's probably like when you do parallel, that's when it gets parallelized, right? So you transcribe benchmark M4A from the French model, and it should give me the segment start time and end time and the actual text. So, okay, model dot transcribe. Let's take a look at faster whisper model documentation. We don't need a lot of these tabs. I tend to accumulate a lot of tabs, and I think I should close them. I wish we could take a look at the other one as well, but I don't know how much time permits. I will just get the benchmark running and basic to work. Oh man, we don't have libcodeian and shared object. Ta-da! Well, that's okay. We should have it. I know where to find the libcodeian, I think. I think so. We'll find out. Right? I mean, if I could do a locate, there's no command. I mean, I could do a locate and find it, or I could go to where my CUDA is installed, which is typically inside /user/local and CUDA. Right? That should have been there, and it should be in my lib folder. No, lib. Okay, where is the, maybe share perhaps? I don't know, I have to explore now. Where is this? But I know it's supposed to be in here somewhere. So probably in my source, I think. No. Where the hell are my shared object files? Compute sanitizer, doc, extra, GDS. Alright, let me do something. Yep, it's supposed to be here now. No. Okay, not even here. It's supposed to be probably somewhere around. Okay, ls CUDA 12.5, maybe it's in CUDA, somewhere in CUDA, or I could look for, okay, yeah, it's inside targets, sure, actually let's go up. CUDA is here. So what am I missing? I'm missing. Where was the error? libcodeian and ops infer.so. Well, I mean, I'd probably have to download it. It's not here. libcdnn ops. Yeah, that's why they said I need to install cdnn. Sure. libcdnn ops is not to be found. I don't think there's anything as such. Let's make sure. Not here, not. Where is it? Not here? Yeah. Cool. Let's actually make it search again. Nothing, right? Yep, that's okay. We should be able to find it. We should be able to find it. Find that thing. Ooh, too big. That's okay, I need to add that thing. I probably have to install the libcdnn ops. Unless it is present inside the Python distributions that we were looking at. Let's give it a shot there too before I give up. I mean, there's no giving up, it's just that I have to install it. Let's find out. No? Oh, it goes into the conda path. That's why. Mini conda. Let's see. Maybe it's envs. There it is. Let's find libcdnn. No? Let's actually see if there is any .so files first. There is, which is good. Right, there's got to be some so files, otherwise I would be very surprised. That means that I have to install it. That's okay. libcdnn, install cdnn, which was the HPC package, right? I think. libcdnn install. Okay, let's go. No, can I just do a download? Please give me download. I don't want to do packages now. Linux. No, no 12. No CUDA 12. Really? I see. CUDA 12. CUDA 12. Let's copy this and maybe imagining that. Oh, there's another one. Let's take this. Why not? Why not? Let's copy this. Cool. Let's go somewhere else. And let's go to downloads. And let's duplicate this path. I think it's a different package, I would say, because it was a libcdnn ops infer. Yeah, so I think it's part of, well, it should be, or it should be a part of TensorRT or somewhere, because it's mostly an inference file, and you know, that's, well, I mean, if it's there in CUDA toolkit. Oh, there's a lib64 I missed. Yep. Let's take a look at lib64 too. I missed that place, didn't I? Actually, let's take a look at the lib64 /user /local /CUDA. And let's take a look at, I think it was targets, right? Why is there only a lib? There should be a lib64 too. Okay. I mean, if you don't know what a shared file, shared object is, it's like you need this for the program to link when the program is running. So you need this shared object. And it's like, it's not necessarily included by the compiler. It's needed during the runtime. So that's why you need this. So I mean, we have libcudart. That's fine. We don't have the, but where is my lib64? That's something I need to look at. Right? I gotta find my lib64. Okay, let's take a look at NVVM and the lib64. No, I thought I saw that. That's right. So let's take a look at lib64 here. Yeah, it should be here now, shouldn't it? libcuDNN. Okay, that's right. No? Where is this? Okay, maybe it's not there. Well, for sure, I thought I checked the... Let's see if there's a cuDN underscore something in here. There's nothing. So my path has to be this. Okay, so now let's extract the thing that we downloaded. What? Bad command. Bad command. What's going on? It's not in JIT. What is the format? Okay. Oh yeah. Let's see. Come on. Well, I'm treating this laptop like it's some kind of a multi-core, multi-socket system. It's really not. It's just a single socket. How many cores was it in here? Let me check. How many cores were there in here? What, 8 cores? Yeah. I'm treating like I have like 100 cores, which is not so much appropriate. 3.5 gigahertz. Yeah, like 8 core, 3.5, and a lot of it, at least I know that some of it is being used by, 1 core is already used by the recording, the screen recorder. The other 2 is like, you know, extraction and stuff, operating system. But yeah, cool. That's okay. Yes, let's... Where is my inference? Where is my inference? Please be there. What? It's not here? So the download does not contain inference stuff? libcodeinn. There we go. Ops 9 is there. Well, I mean, I think they are needing inference ops. Isn't that the case? I think so. Let's check. Dang, where is this ops then? Ops infer. And why does it like give up every time I change things? That's a little annoying. So libcodeinn and ops infer. Where the heck is that? So if it's not here, I don't know where to find it now. Those are just your headers. Yeah, that's cool. Beautiful, beautiful C++ headers. Which is good. I don't know where to find it now. Where do I find the ops stuff? Okay, somebody's having a similar issue from Faster Whisper. Try to remove the system-wide install codeinn from... okay, I can do that. I mean, if I do that... But there isn't anything that the PyTorch download was there with, came with. There's an NVIDIA libcoblas, codeinn lib. I mean, there's gotta be this, right? Okay, so if he's thinking that it is there, which I couldn't find when I started looking for it, but maybe I missed a place. Why don't I search inside here directly inside my lib? Maybe here you'll find it. Actually, why shouldn't I search that thing up here? No? I don't know what to do now. Where is it? There we go. Found the guy. Found the guy. Oh, I shouldn't have used the underscore when I searched. Alright, that's okay. It's this guy. This is the guy. So, I'm gonna have to take this guy and append it to my LD library path. And that should do good. So I'm gonna go vim $source me, and I'm gonna have to do something like this. Export. I learned my lesson. I won't echo it now. I mean, I won't echo it in a create a new folder, new file way. Library path is sweet. Okay, source that file, and now if I go back and run the benchmark, it may work. Now what? Oh, that's right. I have to source here too. Sweet. Okay, that worked. Now we have a different error. No module name faster whisper. Okay. So I don't have a module name faster whisper. And that is because why? Let's make sure I have it. No. Nothing? That's weird. Am I in the appropriate conda? Yeah, I am. Where the heck is faster whisper then? I don't have it. Let's actually take a look at the benchmarks. That's right. I have to do the speed benchmark. And it's saying inference. Alright, front benchmark, utilities, faster whisper. Yeah, that's... I mean, I installed it. That's the reason why I have it installed. No, we don't have AV. No. I don't know what's going on here. Let's take a look. No module named faster whisper. Let's export Python path to... I think I exported to this path. Yeah. Okay, so no module named AV. What is AV? Import AV? So what is AV? It's Pythonic binding for FF and PEG libraries. We aim to provide all the power and control with the library, manage greedy details as much as possible. So it's not installed as a part of my requirements, is that right? Let's take a look at my requirements.txt. Well, it's supposed to be there. Huh. Is piplist even actually doing anything sensible? Because everything it shows says nothing, it's not available even when it's installed, which is very weird. Alright, let's install it. How is this not installed? I thought I installed the requirements file. Well, whatever. If this works, that'd be nice. Okay, I don't know why it is slow, which is unfortunate. my internet's pretty decent. I don't want to worry about my internet at the moment. I actually let that thing be here. So let's take a look at what's going on, and meanwhile, while that's happening, let's look at faster whisper transcription. So this is supposed to be faster, and what is large 3? Right, because that's what we are benchmarking. So if I go to speed benchmark, and if I go to utils and inference, there is an inference function which is pretty much benchmarking the large v3 whisper model. So let's take a look at the model architecture. Model automatic speech recognition and speech translation, trained on 680k hours of labeled data. Whisper models demonstrate a strong ability to generalize to many datasets and domains without the need for fine-tuning. Whisper was proposed here. Whisper Large, the same architecture as the previous large models, except the following minor differences. 128 mel frequency bins instead of 80. Okay. And a new language token for Cantonese. Sweet. Whisper Large model is trained on 1 million hours of weakly labeled audio and 4 million hours of pseudo-labeled audio collecting Whisper Large v2. The model was trained for 2 epochs over this mixture dataset. Yeah, nice. So they took a 4 million hour pseudo-labeled audio. I don't know the quality, but it seems to be better than v2, so I suppose that pseudo-labeling worked out well. The model was trained for 2 epochs over this mixture dataset. Large v3 shows improved performance over a wide variety of languages, showing 10 to 20% reduction of errors compared to v2. The models were trained on either English only or multilingual data. The English only models were trained on task of speech recognition. The multilingual models were trained on both speech recognition and speech translation. Speech recognition model predicts transcription in the same language as the audio. Speech translation, the model predicts transcription to a different language in the audio. That's nice. That's neat. So you just want transcription, it gives you the same language as the audio. And for speech translation, the model predicts transcriptions to a different language. So it takes input English, out comes the French version or something like that. Whisper checkpoints come in 5 configs. The smallest are trained on either English or only multilingual data. The largest are multilingual only. All of 10 pre-trained checkpoints are available on Hugging Face. The checkpoints are summarized with the table links. Large v3, it's about 1.5 billion parameters. Nice. And usage is so and so. Okay. Transcribe a local audio file. Simply press the paths to your audio. When you're in the pipeline, you provide your audio. Long sequential form. In such, v3 remains compatible with transformers chunked along long form. This algorithm should be used when a single large audio file is being transcribed and the fastest possible inference is required. In such circumstances, the chunked algorithm is up to 9 times faster than OpenAI sequential. What the heck is chunked long-form algorithm? Let's see what happened here. Still downloading? My goodness. Why the heck is it so slow? This is too bad. I don't know what is going on. Can we like do a speed test? Find out what's going on here? I mean, my internet's supposed to be a gig speed, but no. I'm getting poor performance, like I'm having a dearth of bandwidth here. And I mean, this is not horrible, but you know, this is really horrible. Okay, let's go back. At least I guess it's an opportunity for us to read some more on Whisper. Transformers chunked long form algorithm. What is that? Okay, so wave to wake at its core let's go to transformers model, and one caveat of transformers is that usually has finite amount of sequence length it can handle. Sure, right? That's what makes it memory intensive, and either because it uses positional encoding or simply because of cost of attention, and transformer is n square. Makes sense. That's, you know, of course, that's why we have these other techniques to mitigate O of n square memory bottlenecks, but it's still not all that good. We still have O of n square, except flash attention try to improve it in a different angle with online accurate tiling setup. Maybe we can take a look at flash attention and understand what is going on there, and we can do a little bit of research and see how we can improve or see what we can do. But this is obviously, I may not be able to for sure get better than the author Treedow of flash attention, but it's something to look at and at least understand in depth what is going on, so we know what is the root cause for performance improvements, right? For sure they're using HBM more effectively, and you know, another question to ask is why are those compilers not able to produce flash attention type kernels? But anyway, that's a different topic, a topic that may be of usefulness at a different video. So coming back, the very large sequence length explodes in complexity and memory. Yep. So you cannot run with finite hardware, even with large GPU like A100. Simply run word to vec on an hour-long file. Your program will crash. Let's try. So okay, so that makes sense, right? Because you can't fit an hour-long transcription, because even if you have an 80 gig GPU like A100, I mean A100 has two flavors, the 40 gig and the 80 gig, and the 40 gig is discontinued. So consider an 80 gig A100 or even the modern H100s. You can't get it to run for long hours because of the very reason that they mentioned, right? That's the sequence length and the memory usage. The program will crash. Let's try. Pip install transformers. Transformer pipeline, very long file, out of memory. This works very long string. So you can chunk it to 10. This works and prints very long string. This whole blog post will explain how to make things work. Okay, sweet. I love this introduction. It basically goes to the heart of why we care, and that's nice. And this is not nice. So let's go back. Simple chunking. The simplest way to achieve inference on very long files would be to simply chunk the initial audio into shorter samples, 10 seconds each, run inference on those, and end up with final reconstruction. Sure, this is efficient computationally, but also leads to subpar results. The reason being that in order to do good inference, the model needs some context. So around the chunking border, inference tend to be poor quality. Yeah, that makes sense. Because, you know, obviously if you're cutting at some weird location and the model is not able to decipher what was said before, then we have trouble making some good outputs, right? So chunk 1, this is poor inference here, and when you do this poor inference, you have like a sad outcome. Well, how do we fix that then? Let me think. If I were to make some guesses, I would say, like, instead of chunking all equal 10 minutes, do some more strategic chunking wherever there is like better outcomes, like maybe between chunk 1 and chunk 2 you could get a better word error rate, and you could chunk over here. So we have to do a little bit of pre-processing before the chunking, and that would get to better results. Okay, this is done. So let's try to run that again. What the heck is going on? NumPy is not there now? Man, something is weird. This has got to be a joke, right? There's no NumPy? Okay, that's why I was reluctant to do this pip install stupid stuff. It is slightly annoying that you have to deal with this. Okay, so now what else is missing? Python is missing now? Yeah, certainly. This is crazy. This is crazy. You don't have C translate now? Well, I was having high hopes, but looks like I need to adjust my expectations. Okay, so let's go back. There are two ways to try. There are ways to try around the problem in general fashion, but they never are entirely robust. You can try to chunk only when you encounter silence, but you have a non-silent audio for a long time. Song or noisy cafe audio. You can also try to cut only when there is no voice, but it also requires another model, and this is not entirely solved problem. You could have a continuous voice for a very long time. As it turns out, CTC structure, which is used by Wave2Vec, can be exploited in order to achieve robust speech recognition even on very long files without falling into those pitfalls. Chunking with stride. Wave2Vec uses the CTC algorithm, the CTC loss, right? I think it's called, it's a pretty interesting name, I keep forgetting. The CTC is, yeah, connectionist temporal classification. We'll come back to that. CTC algorithm, which means that every frame of audio is mapped to a single letter prediction logit. Every frame of audio is mapped to a single letter logit. This is nice. This is a nice animation, right? Because it's every frame of the audio is mapped. This is a frame, and you get to a logit. The main feature that we're going to use is in order to add a stride. This link explains in the image context, but it's the same concept for audio. Because of this property, we can start doing inference on overlapping chunks so that the model actually has proper context in the center. but it's the same concept for audio because this property. Okay, drop the inference logits on the side, chain the logits without their dropped sides to recover something extremely close to what the model would have predicted in the full length audio. Wait a second. Start doing inference on overlapping chunks so that the model actually has proper context in the center. Right? Drop the inferenced logits on the side. So these two guys, the side can drop. Chain the logits without their dropped sides to recover something extremely close. So what does this mean? Chain the logits without their dropped sides to recover something extremely close with the model that were predicted on the full length audio. I'll have to ask ChatGPT that, but let's come back to this. Are you serious? Alright, I'm pretty much like losing track on what is really happening here. The more I see this, the more I find it to be weird. I mean, that's why we have to build a, well, at least that's pretty good. We got to some decent point. That's why I prefer building things inside Docker. So it's like, you know, they already did all this hard work for us and we just can run it from Docker images. But sometimes it could also require a little bit of work. So either way, we may have to spend some time, but spending time on Docker is probably more efficient. So, I mean, that's why Docker was created, right? To pretty much mitigate these type of problems. So there is a file that is being missed. That's okay. I'm gonna modify that file. So that way we can, yeah, it's inside the utilities. This is stupid. Alright, the clipping gets a little annoying. Okay, so benchmark is here, benchmark M4A. Okay, so let's give it a shot now. Is anything going on in the GPU? Of course, core dumped. Well, we fixed it, didn't we? So why can't you find this? That's unfortunate. I thought we had fixed this inside the LD library part. Is this the actual path? Does this even make sense? Or did I just copy paste that path? Oh, looks like the path was wrongly pasted and I didn't even notice that. I'm gonna have to do something about the clip. Okay, so I think we found it inside. Yeah, the path was wrongly pasted thanks to my wonderful clipboard. Likes to paste incorrect things, especially in times like these. And I have to be more cautious about what I do. Yeah, that should do it. Okay, so now maybe I go back here and where was the error? Over here? Okay, so maybe we can try running that again. Okay, that seems promising. I thought we sourced it, didn't I? Why is it still saying is this path still incorrect? Man, I have to. Okay. Coda, mini coda. Of course it's mini coda, right? That's why it's incorrect. It's mini coda, man. Huh? Mini coda. That's right, mini coda. That's what I put my stuff in. Mini coda. I will. Come on. It shouldn't take this long to get it to work. Oh, yay. Good progress. Good progress. I like it. So now we have CUDA out of memory. I just want to see the beauty of 8 GB. Well, I mean, I've seen all the 80 GB systems get out of memory as well. But I like to see my little small, you know, just a baby GPU, old but baby GPU go out of memory. Here we go. Launch, increase the memory allocation. Ta-da, increasing, increasing, increasing. Boom, out of memory. Sweet. Now that we have this, I think we can benchmark some let's actually modify the benchmarking script. So we can benchmark speed benchmark right inside. I keep doing this. That's okay. Call the inference benchmark utils. Right, I wish there was a v2 I could benchmark. Yeah, let's just comment this to v3. Maybe I could do distill v3. Let's actually see if I can distill v3 benchmark it. let's do distill v3 because it's supposed to be, I could even reduce the beam size. Is there a distill v3? Yeah, let's give this a shot before I go to v2, and then maybe we find out that, you know, I could maybe just work with what I have. If I still can't get it, then we do v2. You'll have to download the model. I'll have to clear up all the space after it's done. Seven minutes for this. Alright, so while that's happening, let's go back to what we were reading. Chain the logits without drop sites to recover something extremely close to what the model would have predicted on full length audio. And one nice website I like is, of course, your ChatGPT, or I could do Perplexity. What does this mean in the context of Whisper? Use the large processing them in smaller overlapping chunks. This method ensures that the model has sufficient context for accurate predictions while managing memory and computational constraints. Audio is divided into smaller overlapping segments. Each chunk is processed independently by the model. The overlap ensures that the model has context from adjacent chunks, which is crucial. Dropping inference logits. When processing each chunk, the logits at the edges of the chunk are less reliable due to the lack of context. Yeah, so these edge logits are dropped to avoid inaccuracies. Chaining logits. After processing all the chunks, remaining logits, excluding the drop sites, are concatenated and chained together. This concatenation reconstructs a sequence of logits that closely resembles what the model would have produced if it had processed the entire audio in one go. Handle long input without compromising the accuracy. For example, in Hugging Face implementation of Way2Vec, a similar approach is used where overlapping chunks of audio drops unreliable at the edges and then chains the remaining to form a coherent. So when you drop them, you're bringing them back. When you chain that's when it maintains the coherent. So you're doing it like a multi-stage. Seems like, ooh, nice. There we go. There we go. Ta-da, it is running. 95% distill. Sweet. It's gonna benchmark that file, right? The benchmark M4A. Let's take a look at that file and see how big that file is. I think it's, where is it? Inside my Faster Whisper benchmark M4A properties. I cannot find the duration, but I don't mind opening it, but that'll affect my benchmark. So let me just wait for a moment and then see how big that file is. Sweet, the benchmark runs. That means the Faster Whisper is running on a 1070. and I don't know the audio, so we'll find out if it's actually a translation task or a different task. Or just a transcription task. But we have this Whisper running. My laptop's fans are running full tilt. And this laptop is, you know, the old HP Omen. And thank you. Okay, so if it's a 12 MB M4A file at, what's the encoding? Does it give me clarity? MP4. $13. Okay, it's 13 minutes 19 seconds. Oh, sweet. That's the original audio then. So it is actually the original audio we saw, the TED audio when we. So 13 minute. I can run it on a Whisper on a laptop like this. Sweet. And you know, you could actually do it via Docker. I suggest you try the Docker route and make sure you just add the LD library path. It'll work because Docker is more reliable and it should work really. So that way you don't have to worry about, you know, you don't have to really worry about the conda problems and things of that nature that we are discussing. But if you don't mind having that problem, then by all means follow conda. It's pretty decent. Okay, so benchmark is running. I'll let the benchmark run on my laptop. Let's go back to reading stuff. I'm even surprised my laptop is responding because this laptop is not really that good, and you know, it's working, and so I'm happy. Of course, it's not using all the CPU cores, so that's the other thing. So if you look at the CPU consumption, I am not saturating all the cores. So I have like a few cores being used, and that probably, obviously you can see that this is not very efficiently implemented. You know, the GPU is not always saturated. So we can probably improve the data pipelining or whatever other techniques we can to optimize the offline inferencing. However, given that it actually even works, and that's a good first step, that it actually works and this laptop is able to handle it. I will go back to my top here, and you can see that this is pretty much doing totally fine, so it's not that bad after all. Let's take a look at IO stat. No IO stat, great. And of course, because everything is mostly GPU VRAM usage, if you look at the memory consumption, it's still not bad at all. It's like, you know, 15 what is it, 4-5 gigs. It's nothing. So I mean, it's not nothing, but it is not that bad. I mean, if you're deploying it on a server which has like 64 gigs or something like that, it shouldn't be a concern. And you probably can push this with multiple, you know how NVIDIA GPUs offer MIGs. You can create concurrent launches, and you should be able to get it running even faster. So that's something. And I mean, you could be able to get it running concurrent versions of the inferencing. So, and of course, probably NVIDIA also has a TensorRT optimized version of Whisper. I'm very sure NVIDIA's TensorRT optimized versions exist, and so that's another good thing as well. So if you were to think about how can you build such a system, right? I mean, like actually, let me first take a look at the IO consumption. It shouldn't be really that much, I can tell you right now. Okay, it's sysstack, that's right. I don't know what I was thinking. Okay, so you have really not that much of read writes, right? So you have about 398.9 kilobytes, so that's like what is it, divided by 1000, that's like 0.3 MB per second being read. Yeah, something like that. So let's actually accumulate every 5 seconds or so. Yeah, so now we are looking at not that much at all. So read write is also not that heavy. So this is like a simple, it's mostly GPU bound, and even the GPU bound, you can see that it's not fully efficiently optimized, right? So you can see that it is still running the on the GPU's SMs, and the SMs are not even fully utilized. So it's like 50, 92. It's not that good, but we can try and optimize it if offline inference is something that we care a lot about. I think it makes a lot of sense because so many systems can be deployed with offline inferencing. All you need is like many use cases are available for such a setup. So let it run. I'll let it run, and let's go back to what we were reading. Okay, so let's go down and see what is. Yeah, this is fine. This is good. And let's go here. In practice, we observe that most of the bad inference is kept within the strides, which get dropped before inference, leading to proper inference of the full text. Let's note that you can choose every argument of this technique. So you have a pipeline, and a stride length S is a tuple of left and right stride length with only one number. Both sides get the same stride by default. The stride length on one side is 1/6 of the chunk length. So this is your left stride and right stride, I suppose. With only one number, both sides give the same stride by default. The stride length on one is 1/6 of the chunk length. In transformers, we also added support for a language model to wave to vec2 in order to boost the WER performance of models without even fine-tuning. See this excellent blog post on how it works. Well, I mean, it's nice, they claim that this is good. So they added support for language modeling to wave to vec in order to boost the word error rate performance without even fine-tuning. Nice. Turns out language modeling works directly on logits themselves, so we can actually apply the exact same technique as before without any modification. So chunking large files on these LM boosted model, let's make sure if LM is what they are referring to. What is LM? I thought I'm thinking of language models, but maybe it's different. Chunking on stride on LM models. In the context of language models, as I expected, chunking with stride refers to a technique used in the process of long sequences of text or audio by dividing them into smaller overlapping chunks. This method ensures that the model can handle large inputs efficiently while maintaining context for accurate predictions. Sure. So chunking, the input is divided into smaller manageable chunks. Each chunk is processed independently by the model. Sure. So if you are doing this independently without dependencies, how is the quality not affected? I think independently what they mean is like it's not done in parallel. It's probably having a sequential relationship. Let me check. Stride. The chunks overlap with each other by a certain amount known as the stride. This overlap ensures that the model retains context from adjacent chunks, which is crucial for maintaining the coherence and accuracy of predictions. Yeah, so if you just do a crazy stride, it's not going to work out, right? By crazy, I'm referring to something that's really small. So that is something that could be of challenge. Yeah, you can't have a really small stride. I think this is the third time this is doing. Let's see. Yeah, so application in augmented language models. Augmented language models are language models enhanced with additional capabilities such as reasoning skills and ability to use external tools. These models can decompose complex tasks into simpler subtasks and call external modules like code interpreters to expand context processing ability. Chunking with stride, overlapping chunks, the model retains context, right? That makes sense. Which is essential for tasks requiring efficiency. The processing smaller chunks reduces memory and computational requirements, making it feasible to handle large inputs, right? Dropping the logits at the edges of the chunk and chaining the remaining logits together helps in reconstructing a sequence that closely resembles what model would predict in the full length input. Okay, example in Whisper. In the Whisper model, which is designed for automatic speech recognition, chunking with stride is used. to handle long audio files. Yeah, the dropped in avoid inaccuracies. Sure. Well, I mean, it makes sense. Can you explain the concept of reasoning? How to augment use external tools to extend? Are they processing chunks in parallel? I mean, is it very similar to transformers where everything is done in parallel and the context and the effectiveness is still maintained? If so, how is the quality maintained? This is why I love these tools. I mean, I can do my own research, dig through this. However, I mean, I get this result right away, which is very lovely. I am very excited for the future, and this is why. You can learn a lot with just this. And I mean, you should make sure it's not bluffing you. And you know, that's a problem that the community is working on, which is nice. So, but still, I mean, at this point, even if it gives you a rough estimate, that's a nice, great starting point. So, yes, parallel context windows approach described in this paper processes chunks of text in parallel. Here is how it works while maintaining quality. The long input is divided into multiple chunks or windows of fixed size that fits within the model's original context window. And then you parallel process dependently and in parallel by language model. This allows model to handle much longer inputs than the original context window size. Okay. The attention mechanism is restricted to operate only within each chunk. Okay. This means tokens in one chunk cannot directly attend to tokens in other chunks, for sure. Right. That's how you are able to parallelize this. Positional embedding reuse. The positional embedding are reused across the chunks. This allows the model to process each chunk as if it were the beginning of the context window. Okay. But what if you're referring to something else from the previous one? I think it's... But probably, you know... So that's where I'm a little confused. If it's like referring to a quite a bit previous window, what happens then? Let's see. Output aggregation. The outputs from all chunks are aggregated to produce the final result. The quality is maintained, often improved compared to original context window. By processing multiple chunks in parallel, model can access much longer context. Okay, it's very similar to transformers. You're merging it later, I suppose. By preservation of local context, positional embedding reuse. This technique allows the model to process each chunk optimally, as it always sees the chunk as if it were the beginning. No additional training. PCW, which is parallel context windows, doesn't require any changes to the model architecture or training. Empirical results. Multi-paper demonstrates improved performance on various tasks, including in-context learning, multi-hop questions, and retrieval augmented question answering, showing that parallel processing approach can maintain. While this approach may not capture long-range dependency that can span across chunks, offers a practical way to extend. Paper or architecture to refer from. Okay, so revisiting parallel context and chain of thought, deterioration. Well, I mean, I want to see the actual architecture for the the audio version. Okay, well, so let's take a look at this. You have the encoder block and the decoder block with the cross attention, learn positional embeddings, next token prediction. What's going on? Okay, it's still, maybe this is the third one then. My estimation was wrong because I told the previous one was the third one, but okay. Oh, because their numbers were based on a 4090, I think. Let's go back. Their numbers, right? This 54 seconds, where is it coming from? This 54 seconds on, this is large V2. Sure, I did distill V3. So obviously I have to expect a higher benchmark clock time. What also I need to expect is that this is a it's yeah, see, this is 3090. What I have is a 1070. So of course the clock speed on the 3090 and the 1070 is different, right? So if I look at NVIDIA 3090 and the 1070 clock speed, yeah, so let's take a look. I mean, this is too damn old, right? Mine is too damn old, and it actually still works. That's fine. Can we get like memory clock and other specs, please? Yeah, I'm glad it's actually 163% faster on the effective speed. How do I find the specs? There's no way to see the spec. Okay, but you gotta listen to their numbers here. Unless, of course, maybe I should build a website that'll like do just NVIDIA GPU specs comparison. Right? Let's see. 3090, 29.8 teraflops higher floating point performance. Shoot, this is like, this is like 5 and this is 35. It's 7 times already, right? And 3 times the VRAM. Memory clock, there we go. Memory clock is 8,000 megahertz versus 19,500 megahertz. You can see there's a big difference, and so I should expect a higher time, probably like 3 to 4 times more or something like that. So memory bandwidth is 256 GB per second versus 936, and that's another thing to consider as well, right? So what is it, 256, 512, 768, close to 4 times or maybe 3.5 times, right, faster on your memory bandwidth. So I have to just relax and read some more stuff. Okay, let's go back to my faster whisper. Faster whisper benchmark. Speed benchmark. I am repeating 3 times, and once the thing is done, what is number 10? Run times, time it dot repeat. What is number? How many times to execute statement? So the way time it works is to set up code once and make repeated calls. What is number? Repeat versus number. Yeah, that's a little tricky. Oh my goodness. So are we doing a 30 run? Internally there's a loop like this. Oh my goodness. Am I running 30 times? Okay, that explains why I keep seeing this time and again. So I'm running this 30 times. The benchmark runs it for 30 times. Alright, that's considerable. I see. Okay, the output is the average. Alright, so if I don't think I want to run 30 times. It makes no sense. But this is working. That's good news. What is also good news is how can we take this and apply it to our data set, right? Our use case. If we can get that to work, that'd be nice. Now let's take a look at the Whisper model, right? That's essentially what we need to look at. We can come back to reading again. Further ado, let's just quickly go through this. I guess we're almost there. So where was I? I was at the chunked model, right? Chunking. Okay, so there is a sequential long form version of this as well. Alright, I'm looking for my chunked version. Where was I at? Yeah, let's just go down 1.5 billion. We looked at all this. We looked at the sequential long form. The should be used in either of the following scenarios. Transcription accuracy is the most important factor and latency is less of a consideration. Yes. This algorithm uses a sliding window for buffered inference for long files and returns more accurate transcriptions compared to the chunked. The sequential long form algorithm should be used in either of the following scenarios. The transcription accuracy is the most important factor. Latency is of less consideration. You're transcribing batches of long audio files, in which case the latency of sequential is comparable to chunked, while being up to 0.5. Yeah, that makes sense, right? Because if you sequence things, you will have less error rate. So if latency is really not that important, or if your transcription accuracy, let me put it this way, right? Transcription accuracy, if it's the more important factor, then you are better off doing the sequential long form as opposed to chunk long forms. The pipeline class can be used to transcribe long audio files with sequential. What you do is you load data set, you do blah blah, and obviously this version of faster Whisper we have should be much faster than these ones. So let's not worry about the Hugging Face implementation. We'll look at the code too. Maybe not today. I think it's too late. Already the stream is running for a while. Yeah, so large V3 remains compatible with transformer chunked long form algorithms. The fastest inference is required in such. If you want super fast inference, the chunked algorithm is up to 9 times faster than OpenAI's sequential long form. Distill paper. Yeah, why don't I look at that very quickly? Let's see. I just want to look at the architecture. Layers, width, heads. Ooh, I like Radford. Nice. Yep. Okay. So knowledge distillation, pseudo labeling, fine tuning, KL divergence, chunked long form transcription, speculative decoding. Accelerating inference autoregressive by employing faster assistant model. The assistant model generates a sequence of candidate tokens, all of which are verified by main model in single forward pass. Okay. By generating faster assistant model, only performing validation forward passes within the main model, the decoding process speeds up significantly. By generating the faster assistant model, only performing validation forward passes with the main model. See, this is not going well with me. Obviously, there's more to the speculative decoding. I read it once, I've forgotten. If you have a candidate model that's generating, right, and isn't the candidate model already doing the job? Okay, I suppose the candidate model is maybe less precision or something like that. That's only when it makes sense. But if your main model is also doing a faster thing, I don't understand how exactly it's better, but I'll ask Perplexity in a moment. It's only kept if all previous candidate match the validation tokens. Consequently, speculative decoding ensures generated output match. Okay. I think I have an idea, but I'll come back to that. Decoder block, KL divergence, encoder, encoder, cross attention, decoder. That's the architecture, right? Nice. So you have all these encoder blocks, 32 running in parallel, and you have a decoder block that'll take your cross attention, KL divergence with teacher output distribution, next token pseudo labels. Okay, the benchmarking is done. Did it do it 30 times? I don't know. I need to check. And let's see. The student's decoder consists of 2. That seems fine. I'll have to spend more time looking into the architecture in more details. Yeah, seems cool. I think it's where the part that is actually is a general common sense I should know, but I need to ask this. How is this speeding up? Why can't I don't exactly well, actually, let me do it this way. If the teacher is still decoding to validate, isn't that waste not as good as system model generate candidate tokens, where then right assistant model smaller faster model generates, sure. Model designed to be much quicker than main model, allowing it to produce multiple tokens, sure. The main model, which is more accurate but slower, validates the candidate tokens generated by assistant model. Yeah, validation process involves checking if the candidate tokens match, sure. Yeah, this is pretty much explaining the speculative decoding, right? The ith candidate assistant model is only accepted if the previous tokens match the tokens predicted by main model, sure. If the candidate token is rejected, main model corrects by generating the appropriate token. Okay, that's where the improvement comes from. So it's like delta, and you're only doing no fixing, right? Only rarely you fix. Let's see. The speed up comes from parallel generation of candidate tokens by the assistant model and the reduced number of forward passes required by the main model. The assistant model can generate multiple tokens in parallel, significantly reducing the time, right? The main model only performs validation passes, which are fewer in number compared to generating each token sequentially. If the candidate tokens from the assistant are accurate, the main model's workload is minimized just to validation, which is faster than full token generation. I mean, to validate, aren't you generating? Maybe you're not generating, that's what it's implying here. So assistant model generates 5 candidate tokens in one go. The main model then validates these tokens in single forward pass. I see. So you just do one pass. That's where it's improving. If all tokens are correct, the process moves forward without additional computation. If some tokens are incorrect, only those specific tokens are corrected by main model. And because it's just like the same way we do autoregressive waves, right? You just take it back, so you're not effectively doing it all at once. So that's the benefit. That's where the speed up comes from. Got it. The process moves forward without additional computation. If some tokens are incorrect, only those tokens are corrected by main model. Studies have shown that speculative decoding can achieve 2 to 3 times speed up in practice. For instance, the fast inference from transformers by speculative TFI achieving significant acceleration without changing the output distribution. Offloading initial token to a faster model, limiting the main model's validation. This approach leverages the efficiency of assistant model for parallel token generation and reduces the computational burden on main model. Okay, I can see. Sure, this is nice. Fast inference. Where was I? This one. Let's take a quick look at the code and then I can conclude today. I will just quickly take a look at the code and see what's going on here. Whisper model. Where is Whisper model coming from? Transcribe. Okay, so transcribe. I click on transcribe. Word, segment, transcription options, info, how many lines are there? 1200 lines? Sure. Okay, seems nice. I think we should spend more time on this if we have to improve or make it better. But for now, seems like if we spend time, we can maybe understand this code base and see what's going on. Okay, so this is what I ran on a 1070 and so it took 30 minutes ish, right? Wait, it didn't run 30 samples? It didn't run 30 samples. So if it didn't run 30 samples, why would I minimum execution time is 72. What is this? This is printing the benchmark. Print the runtimes. Okay, yeah. So print the runtimes. Right, so that'll give you the 3 runs printing, but inside each run it's probably like running 3 times. Sorry, 10 times. I'm looking at the words. When he says that the view of the space, the planet is blue, it's the territory. It's not horrible, it's pretty decent. But I don't know if it's exactly matching. And this is how much my Tmux allows me to go back. But there's probably a way to download text. That's another reason why download terminal output. There's a way to download this. Control Shift H and save. Control Shift H. Oh, I can hit save. Why? How do I save it? It's not doing anything. You can do this with regular terminal? Huh. No, this is not what I want. I should have teed it. I should have teed it instead. But I know Kitty has a way to do it. Kitty save. And Kitty save log content or stdout content. Never mind, I'll look into it later. But there's a way. Let's see. Kill, respawn, spin, vertical split, copy line. Alright, that's probably it for today. I think we just got this running and it works. And we just looked into the code and we saw that Whisper has different models, and there is you know, if you have a 1070, this will work. You can add it, and there's like chunked approaches, there are non-chunked approaches. If you look into the code, maybe all of that will start to make sense. We certainly didn't spend a lot of time inside the code, but we just very quickly glanced it. We got it to run, and I think that's a fair ending point for now. We can also benchmark the memory and GPU power, and that seems like a cool thing to check out as well. Okay, so thank you so much for watching. I didn't plan or do any groundwork. I thought I'd let it be as natural as it could be. And please comment if you like anything like this, and if it's not useful, well, oh well. I'll try making better videos and see how that goes, and if it doesn't work out, okay, maybe it's not useful anymore. Thank you so much.